So the goal of using a Pew scoring matrix is to select one or two of the best solutions. You want to use a scoring Pew matrix after you've used a screening Pew matrix. So if you recall in this diagram, we've gone from many ideas through the screening Pew matrix to a few, maybe 5 or 10. In this last step, we're going to use a scoring Pew matrix to reduce the number of ideas down to just 1 or 2. There are two types of scoring Pew matrices, the priority checkmark and the Pew scoring matrix. In this video, we're going to go over how to set up a scoring Pew matrix. So like a screening Pew matrix, a scoring Pew matrix allows you to rank concepts against design criteria, rank the solutions, combine and improve, and select solutions for further evaluations. We're going to use the same 7 steps in setting up and running a scoring Pew matrix as we did for the screening Pew matrix. However, there are 4 differences. The first is that the design criteria are weighted in a scoring Pew matrix. So you're going to assign a weighted percent to each of the design criteria in your scoring Pew matrix. The more important design criteria will have a higher percent. Typically, you want to select round numbers as your percents, such as 20 or 25%, rather than fractions like 23.4%. The design criteria weightings should be consistent with the rankings of the pairwise comparison chart. The second difference is that we use a 5-point scale for the scoring Pew matrix rather than the 3-point scale that we use for the screening Pew matrix. So we'll use the numbers 1, 2, 3, 4, and 5 for the 5-point scale, rather than the plus, minus, and 0 for the 3-point scale. Now it's very important that you define the value, range of values, or attributes associated with each of the rankings of 1 through 5. I just want to remind you how important it is to use data to inform the selection of 1 through 5 to put into your scoring Pew matrix. You really want to avoid guessing, opinions, or intuition. Instead, you need to do a deep dive, do lots of research, draw detailed sketches, do some calculations, and talk to experts. I cannot emphasize enough the importance of using good numbers in your scoring Pew matrix, because in the end, this will determine your solution, leading to either the success or failure of your project. As an illustration of how to define the 1 to 5 ratings with numerical values, we're going to go through the design criteria for the spoon design. So let's first look at time. The design criteria was to cut independent feeding time in half. So for rating 1, the time would range from the regular feeding time to 60% of that feeding time. Rating 2, 40 to 60% of the feeding time. Rating 3, 30 to 40% of the feeding time. Rating 4, 20 to 30% of the feeding time. And rating 5, less than 20% of regular feeding time. For transportation, we set the design criteria that greater than or equal to 80% of the food is transported from the plate to the mouth. For rating 1, we set that 0 to 45% of the food is transported. Now, if you look between ratings 2 and 5, we're going to increment up by 15% for each. 45 to 60, 60 to 75, 75 to 90, and then for rating 5, greater than 90%. For ease of use, we've set the design criteria that's greater than or equal to 70% of pediatric patients with arthrogryposis can grip and use the device without assistance. We've taken the range of 0 to 100% and split that up into increments of 20, such that for rating 1, we have 0 to 20% of pediatric patients can use and grip the device. For rating 2, 20 to 40%, rating 3, 40 to 60%, rating 4, 60 to 80%, and finally, rating 5, 80 to 100%. For lightweight, we set the design criteria to weigh around 2 to 3 metal spoons, or less than or equal to 200 grams. Here, we set rating 1 with a weight greater than 500 grams, and rating 5 is a weight of less than or equal to 50 grams. We set the design criteria for durability to last at least 1 year. As you notice, times range from less than 6 months to greater than 3 years on our rating scale of 1 to 5. For cost, we set the design criteria to be less than $20. And again, here we have increments from $40 to 20 to 10 to 5 from our 1 to 5 rating. with each level for each design criteria set. This allows a team to move through filling out the Pew matrix in a very systematic way. Mini recap. The first difference is that design criteria are weighted in a scoring Pew matrix. We just spent time talking about the second difference, which is using a 1 to 5 rating scale. The third difference is that the standard in a scoring Pew matrix is a value of 3, not a 0, as it would be in a screening Pew matrix. The other big difference with the standard value is that it can vary across solution. It doesn't need to be within one solution. In other words, the value of 3 as your standard can move across the solutions as long as you have at least one standard value of 3 for each of the design criteria. The fourth difference is the process used to calculate the selected solution. Here what you do is you multiply the weighting by the rating to get a value, and then you sum all of those values down to the final score. Scores should range from 1 to 5, with typical values ranging from 2 to 3. In summary, scoring Pew matrices are the final step in selecting a design solution. These tables are very similar to the screening Pew matrices, with the exception of those things discussed in this video. Scoring Pew matrices are successful when they are run with informed numbers.